Bonsuelo, everyone. Today, we're actually going to start taking a look at graphs. It's not a really complicated lesson, but again, I want to make sure you know what it is you're trying to do. So I'm going to write a bunch of stuff down here. You don't need to write any of it down. Just listen, okay? Now, and for sure, don't write this first part down. What if I ask you to do this? What if I ask you to solve 2x equals 6, and you tell me x equals 3. Well, why does x equals 3? Why is that the solution to the equation? Again, anytime you solve an equation, what you're doing is finding all the values that can be substituted for the variable that will make the equation true. Okay? That's all you're ever doing with an equation, is you're trying to make the statement true. Okay? Well, how about something like this then? Y equals the absolute value of x. What am I asking you to do? What I'm asking you to do, it's an equation. I'm asking you to do the same thing. I'm asking you to find all the values that can be substituted for in this case, there are two variables though, all the values that can be substituted for the variables in the equation that will make the equation true. Again, you don't need to write that example down, but I just want to show you something. Okay, I'm just going to kind of make a real rough sketch here. And by the way, if you don't like mark, you have to put some sort of marks on the axes. But if you don't label them 1, 2, 3, we'll assume they're 1, 2, 3. Okay? If you don't want them to be that, you have to label them. Okay, so let's find something that makes this true. Well, does the point 0, 0 make this true? Okay, you plug in 0 for x, you plug in 0 for y. Yeah, it makes the statement true. So you have the point 0, 0 make it true. How about the point 1, 1? Does that make it true? Yeah, you plug in x as 1, you plug in y as 1, and makes that statement true. So the point 1, 1 makes it true. How about the point negative 1, 1? Does that make it true? You plug in negative 1 for x, you plug in 1 for y. Yeah, that makes it true. Okay, then why isn't this the graph? Every one of those, all three of those points make the statement true. But remember, you don't have the graph till you have everything that makes the statement true, till you have all values, in this case, all x, y pairs that can be substituted for the variables that will make the equation true. Okay, well, how do you go about doing this? What I'm going to talk about today is just graphing in general. I'm not going to talk about any particular type of graph, although I am going to show you some examples and some examples that you should know. But what I want to show you is, what do you do when you don't know what to do? I'm going to show you the worst way you can possibly make a graph, but it will work for any equation. Okay? Now, eventually I'll show you shortcuts to graphing. And when I show you a shortcut, you can't use this method that I'm about to show you. I won't accept it. But if I give you something and you've never seen it before, okay, I'm going to show you what to do, and it will always work. Again, you don't need to have this example written down. As I said, I'm going to get rid of it. Just kind of trying to give you an idea of what we're trying to do. Okay, this is what you do when you don't know what to do. If you don't know any shortcuts, you make an XY table of points until you see a pattern. That's it. So there are 4 basic types of graphs that I mentioned in the last video. 3 of them are here, linear, quadratic, and cubic. And then again, I'm adding that absolute value equation on at the end. But I just want to show you what I mean. So I'm assuming you don't know how to graph any of this. Okay. So what we're going to do is make a table. Okay. And I apologize for my beautiful writing here, but okay. And we're going to plug in values for x. Could you plug in values for y? Yeah, but it's pretty much typical. You plug in values for x. So we're going to plug in values for x, okay, and then calculate what y is. So what's the best number to start off with? It's not 1, it's 0, okay? And if you plug in 0 for x, you get 0 for y. What number would you pick next? 1. If you plug in x, you get y is 1. What's the next number you pick? Not 2, okay? You got to pick negatives. Don't ignore the negatives. So let's plug in -1. And if we plug in -1 for x, we get -1 for y. Okay, by the way, it doesn't just have to be whole numbers. You know, it can be like half, a third, 0.7. It can be anything, but usually I don't do that if I absolutely need to. Okay, well, let's plot these points. So we got 0, 0, 1, 1, and -1, -1. Now, the point I'm going to try and get across is this. How long do you need to make this XY table for? Okay, and this is what I always tell people. As soon as you're willing to pull out $1,000 and bet me, Mr. Lieblang, I know what that graph is doing. I'm sure of it. There's no way I could be wrong, and I'm willing to bet $1,000 I know what it is. As soon as you're willing to do that, that's when you can stop making the XY table. Okay, so first of all, this is a linear equation. A linear equation graphs is a line. Okay, so you know it's a line, so you should know it's a line. So that should be good enough. But if not, you can find 2 and -2. And if you plug those in, you get 2 and negative. It's pretty straightforward. But again, as soon as you're ready, what do? Okay, is this the graph? No, it's not. Remember, you only have the graph once you have all values that can be substituted for the variables that will make the statement true. This is 5 values. It's not all the values. So you have to draw the entire graph. You have to draw all values. So I'm going to do that. Now, this is still not the graph because this is not all values, because the way I've drawn it, it ends over here on the right and it ends over here on the left. So if I wanted to continue in order to show all values, you need to put the arrows. This is a graph of y equals x. It's showing all values that can be substituted for the variables that will make the statement true. Okay? All right, let's take a look at quadratic y equals x squared. All right? Again, we'll make the xy table. And we'll try 0, 1, and -1 and see what happens. Square 0, you get 0. Square 1, you get 1. Square -1, you get 1. Okay, let's plot those. So we have 0, 0, 1, 1, and -1, -1. Now, if you'd be willing to bet me right now, you know what that's doing. You'll probably, or at least half of you will probably lose your $1,000. I'm going to draw something on here. Don't do it, because then I'm going to erase it. But what could this graph as? Well, right now it could be V-shaped. Okay, that's one possibility. What else could it be? It could be U-shaped. Okay? And this is why I tell you to do it in pencil. It's a lot easier to do this in pencil. So right now, you don't have enough. Okay? All we've got is 0, 0, 1, 1, and -1, 1. So let's try 2 and -2. And if we square each of those, we'll get 4. So we get 2, 4, and -2, 4. Now, at this point, could you make a V out of this? No, you can't make a V out of this. You can't make straight lines going from 0, 0 out, okay? If you need more, you could go for 3 and -3, et cetera, but at this point, most people would be willing to bet me that it's a U shape. Whoa, what happened here? Okay. So it's a U shape. And every quadratic equation is going to have a U shape. Okay? Let's go for cubic. Sorry. And again, you should, pause the video and give it a shot yourself. Okay, let's go for 0, 0, 1, and negative 1. And if you cube 1, you get 1. Cube negative 1, you get negative 1. So we have 0, 0, 1, 1, and negative 1, negative 1. And you go, oh, it's a line. But it can't be a line because it's not a linear equation. Okay, so you don't know what it is. If you're willing to bet me $1,000, you just lost $1,000. Okay, so we got to keep going on this one. So let's try 2 and negative 2. So 2 cubed is 8. Negative 2 cubed is negative 8. So we have a point there. Got a point down there. Okay. Now, you may need more. That's fine. But at this point, that's probably like about the minimum you'd need. So what is this going to do? This part kind of curves up like that. And this part kind of curves down like that. Okay. And that's what a cubic is pretty much going to look like. Okay? But you don't have to have these memorized. Linear equation is going to look like a line. Quadratic equation is going to look like a U. Cubic doesn't always look like that. Okay, actually, a cubic can look a little different. But someday I'll explain to you what a cubic always looks like. But you know what? I don't expect you to have any of this stuff memorized. It's fine with me if you know how to do it. It's fine with me if you don't. The thing you need to know is if you don't know what to do, you make an XY table until you see a pattern. And until you're willing to say, Mr. Lieblang, I'll bet you $1,000 I know what that graph is doing. Okay? And want to remind you, we are graphing equations. Notice there are two variables here. We're doing this on two axes. Okay, there's one more I'd like to throw in, and I mentioned it last time. I didn't have it on the, on the printed page, but so you're probably going to have to do this on the back of the paper that I gave you. But let's take a look at an absolute value equation. Y equals the most simple one, absolute value of x. Okay, and I'm just going to hand draw the XY axis, for which I apologize. It's not going to look too good, but okay, let's make an XY table. That's a perfectly straight line there on my XY table. It's a thing of beauty. Okay, let's go for 0, 1, and negative 1. So the absolute value each of those is 0, 1, and 1. So we have 0, 0, 1, 1, and negative 1, 1. And notice I've got the same 3 points that I had for the quadratic, 0, 0, 1, 1, and negative 1, 1. Okay, so again, what could I do here? I could make this into a U, or I could make it into a V, so we don't know right now. So let's go for 2 and negative 2. And if we take the absolute value of those, we get 2. So we get 2, 2, 2, negative 2, 2. And at this point, you can't draw a curve. You can go to for 3 and negative 3 if you want, but hopefully it's pretty obvious here. What do we have? We have a V. Okay? So the basic idea is make an XY table. Until you're willing to bet me, you know what's going on. But I will tell you this. What are you doing when you're making a graph? You're finding all the points that can be substituted, all the XY pairs that can be substituted for the variables in the equation that will make the equation true. And I'll just tell you a linear equation, that's a polynomial of degree 1, x to the first power, no other symbols around it. It's always going to look like a line. Quadratic, x squared. There's no like square roots or anything else around it. What's it always going to look like? It's going to look like a U. Cubic, I'm not so much worried about that one because that one can change a little bit, but okay. And what's an absolute value equation always look like? It always looks like a V. And again, how do you tell what type of equation it is? You look at the variable. The variable will tell you what type of equation it is. I hope that is helpful to you. I hope that is like really making your day. Like you say to yourself now, self, you know what? I have something to bring up at the dinner table tonight, something that will excite my little brother or sister, my mom and my dad. It's just kind of fun. This is fun. At least I hope you think so. Have a good day, everybody.